Okay, Ph261 Chapter 9 homework problem number 2. It's in a common but dangerous prank, a chair is pulled away from whoops. Let's just pretend I wrote these later. A chair is pulled away from a person that is moving downward to sit on it, causing the victim to land hard on the floor. Suppose the victim falls 0.5 meters. The mass that moves downward is 71 kilograms, and the collision lasts 0.074 seconds. So we have a delta y of 0.5 meters, a mass of 71 kilograms, and the time is going to be, or it could be change in time, because it's starting at 0, but, same thing. So change in time is 0.074 seconds. Now, we know from the kinematic equations that V initial, or V final squared minus V initial, square goes to the top, squared minus V initial squared equals 2GH. Well, GH, what that really is I believe it is 2 acceleration. Let me check really quick. Well, still, in this situation, when dealing with something falling to gravity, it's going to be G, and it's not just H, it's delta H, so it's going to be the change in, let's just call it delta Y. Change in H, delta Y, same thing. And we know that the initial velocity is going to be 0. So we're left with velocity final squared equals 2 times 9.8. And the delta y in this case is 0.5. And to get rid of the square here, we square root this side. So velocity final, I don't have to write it twice. I can just say here equals 3.13. Okay, now that we know that, we have the velocity. We know that the change in P here is equal to mass times velocity final minus mass velocity initial. So, we again know velocity initial is 0. So, our change in momentum here is equal to 71 kilograms times the velocity final, 3.13, which gives us 222.26. And it says, what is the magnitude of the average force acting on the victim during the collision? Now, the magnitude in this case for impulse, okay, we know that that is force with the dot product of change in time. How do we know what the force is? Force equals the delta P, change in momentum, over the change in time. Okay, once we know this, we can get the force, or the magnitude of the force acting on the victim. So what we do here is we do 222.26, divide this by 0.074, and we get right here, so this is going to be A, and for B, we're going to get 3,003, and that's B.